Hi everyone, am I audible?
Yes, sir.
Awesome. Let's wait for 5 more minutes, then we'll start the workshop. Has everyone set up the VirtualBox and installed Ubuntu 16?
Yes, sir.
Okay. Right now we only have 7 people here, and I can see 2 organizers. So, are more people coming?
Am I audible to everyone?
Yes.
So am I audible to everyone?
Yes, Dipanshu.
Okay, so good evening everyone and welcome to the ROS workshop organized by IEEE PEC. It is indeed my great pleasure to welcome among us one of the prestigious alumni of our institution. So without any further ado, I would like to introduce Mr. Kulbir Aluwalia, who passed out in 2019 from the electrical batch PEC. He is currently pursuing his master's in robotics from University of Maryland. Some of the few achievements that I am compelled to tell about to give an idea regarding his expertise in robotics are: he was the winner of the Texas Hackathon 2019, a silver medalist for the best major project in the 2019. However, Kulbir sir's introduction cannot be completed without providing his invaluable contribution to the IEEE society as a technology head. The level of technical projects, the level of technical projects and workshops wouldn't be the great as without you, Kulbir sir. Kulbir sir has an expertise in many fields ranging from robotics to OpenCV, neural networks, etc. So in conclusion, we really missed you, sir, and it feels great to welcome you. It doesn't only provide us a great opportunity of nostalgia, but also an opportunity to reflect upon our learning and achievements over the past 4 years. And I like your heart very much. Very good.
या चलो ठीक है, अब वर्कशॉप शुरू करते हैं. ठीक है, तो सबसे पहले हम टर्टलबॉट की जो गिट रेपो है वो देखेंगे एक बार, और इसका जो लिंक है वो मैं चैट में डाल रहा हूँ. ठीक है, अपना इस रेपो से हम सारी कमांड्स जो हैं वो एग्जीक्यूट करेंगे अपनी वर्चुअल मशीन में. एंड आई होप सबकी वर्चुअल मशीन चल रही है. यस नो कुछ भी चलेगा. So guys, is your virtual machine working?
Yes, sir.
Okay, awesome. Okay, so now I hope that you have opened the Git repo for Turtlebot 3, and we will begin by installing some packages. And so it takes a little bit of time to install it, so that's why we'll begin with installing the packages. Okay, so first of all, execute these start from the top. Okay, so have you guys made the Catkin workspace? And have you done the Catkin make, or should I cover it quickly? Anyone who has any trouble there or hasn't set up ROS can like text me in the chat. Okay, so I hope these two commands have been done. and you have you just now change to the Catkin workspace and the folder inside it, which is the src folder. Okay, so src folder is where we have our ROS packages. So here we will be installing the packages corresponding to Turtlebot 3, and just cd to that directory, and execute all of these commands one by one. It will take some time depending on your internet speed. So I already have them, but you should execute these commands one by one. For the people who have joined just now, so I'll just text this link on the WhatsApp group, and you have to go to this Git repo and execute the commands corresponding to the installation of packages required for Turtlebot 3 for ROS Kinetic. So it's in the towards the end of the README. Okay, I'm sending this link on the WhatsApp group. Open this repo and execute the commands one by one, starting from here. This, okay. Okay, so after you have completed the git clone for these packages, all you have to do is go to come one directory out and do catkin make. So this will make all of the directory structure, organize everything, and if you have any errors here, you should post that error in the chat. Does anyone have any error when they do catkin make? Okay, so you can continue to do these things, and while these things are executed, I can start with the presentation of the ROS basics. Okay, and you also have to install these packages. So this one, I think it's like 200 MB. So this one, these commands will take some time. So you can execute these commands side by side, and I'll start with the PPT for the basics. Okay. So So if you are interested to read about what I will cover today in more detail, you should consider this book called A Gentle Introduction to ROS. And this one is with C++. And you can also find the corresponding commands, the corresponding Python commands easily if you search them. But this book has a very good introduction. and like how to use a terminal and all of that stuff I've already covered in the videos that I posted. Okay, so ROS uses Python and C++ both, and it is up to you which language you choose, like Python or C++. Like both of the languages have their advantages and disadvantages. And then we'll be covering some basic ROS terms like nodes, topics, what are messages, and how do like nodes publish or subscribe to some topic, and like what is ROS core, all of those things. Okay, and we'll also see how to like make the Catkin workspace, what's the directory structure, and all of those things. Okay, now so yeah. So obviously, like if you choose Python to write your scripts in ROS, then it's obviously faster prototyping, and like you can use libraries and functions from libraries, and it becomes easier for you. You don't have to start from scratch. But there are some disadvantages as well. It's very slow, and like you have to know the libraries, how to use them. And the thing with Python, like it likes to use only one core, and then like all of your other cores are just doing nothing. So you can consider using the multiprocessing library, but that takes time. Okay, so see, so that's the disadvantage with Python. And like if you make a lot of functions and the classes and all of that stuff, like it can get disorganized very fast. Then we have C++. So C++ is really fast. Like you can feel the difference in the execution time in everything. And C++, like it goes well along with the low level hardware. It has real-time performance, so it's very important that you master this language, because like even now, even after so many years, C++ rules. And for projects which are responsive, and for projects that require you to like take your decisions in real time, you have to use C++. Like if you have a autonomous navigation drone, or if you have an arm that's serving in some restaurant or something, you have to take decisions in real time. You cannot like wait, because like humans don't wait. You have to like be fast. So to be fast, you have to use C++. Okay, so the cons, it's a little bit complex, and debugging is like you miss one semicolon or anything, and you just you know that. Okay, so now what are nodes? So nodes are like mini programs in ROS, and each node does some particular thing. Okay, like I'll give an example. So see, right now I am running an empty world with a Turtlebot in it. So this particular Turtlebot is the waffle. Okay, and so when we do ROS node list, we see that there are 3 nodes running, and each one of them is is a program in itself, and it subscribes to topics, publishes topics, so publishes 2 topics. So a node is like it's a program in itself, and they communicate by passing messages. So messages are the data. Okay, zoom a little bit. Okay. Okay, is this fine? I'm assuming it is. Okay, so messages consist of the data that is communicated between different nodes, and topic is the path through which the data is communicated. We will cover this later, and so yeah, so communication between nodes, this occurs using messages, topics. We also use raw score and the concept of publishers and subscribers. Okay, so again, I already told this, that what is a message? A message is a packet of data. Okay, so suppose this blue what is this, 1 2 3 4 5 6 7, yeah, this blue heptagon, this is like a node which is publishing a message. So this arrow is going out, this is publishing a message, this is generating some data. Okay, so that message is a packet of data. Okay, so it will have some like it will consist of floats or integers or something, and all of that is predefined. And so here, like so this node publishes data to a topic called images, and then there is some other node which subscribes to that topic slash images and reads that data. So the topic is the channel, and the message is the data that is sent from one node to another node. Okay. So like a topic like slash images, there might be one topic, and there might be three nodes that want to publish to that topic. Suppose you have like 3 cameras, and you have only one topic slash images. So they might take turns to publish that topic. And again, like I covered this, a topic is like a named channel through which nodes send data to other nodes. So there is this node in the end which wants to see the image feed from these 3 cameras. So it subscribes to the topic called slash images. Okay. So the subscriber here, slash node underscore s for subscriber. This subscriber only needs to know the name of the topic, and it does not need to know which node publishes to that topic. Like it just needs to see the image from the camera, right? So this is to simplify things. And okay, so now let's talk about raw score. So so raw score is a collection of nodes and programs that are prerequisites for a ROS-based system. Prerequisites for a ROS-based system, and like before you start any script, before you start anything, you start raw score. So it loads all of the nodes and programs that are required later in the pipeline. And so raw score must be running before any ROS node is launched. Okay. So to run raw score, all we need to do is just like enter ROS code in the terminal, and it starts the core services required for ROS programs. And yeah, so if you launch ROS code in the terminal, you have to like launch another terminal for other programs. That is why we install Terminator, and in Terminator you can have like 4 or 5 terminals in an organized way. To terminate ROS code, you use Control C. Okay, and so there is a publishing rate at which messages are published. So in this diagram, so you see all these nodes. They publish their data, their messages at a rate like 1 kilohertz or 100 hertz. So 100 times a second they publish that message. Okay, and like a subscriber which like, so sorry, here we talk about the publisher. So here a publisher, this one /camera, it is advertising. It first advertises this topic called /images to the master. So the master is launched when you launch ROS code. Okay, I'll show this particular we will launch ROS core, and we will also see the URL at which it is available. So another ROS core is running. Let it shut down. Yeah, now. So see, so here when we started ROS core, we see that it is available at this link, and it starts the master. Wherever, at whichever system, like you have 2-3 systems, you're running ROS on all of them. The system on which you run ROS, that is the master of the system. And like see, so here the camera first advertised this topic called images, that I want to publish images, and then a topic was created, images, and then the camera started publishing to that topic. Now some other node like a /viewer wants to view those images, so it will subscribe to master, and the master will connect both of them, the camera which is publishing the images and the viewer which wants to see those images, and they are connected through this path called topic. And now okay, so this one is just like a feature of ROS, that you don't need to publish first. You can have n number of subscribers waiting for a topic to be published, so that like they can subscribe to that topic as soon as it becomes available. So you can have many viewers, and as soon as the camera feed starts, they can directly be connected. Okay, and okay, so now I see that a lot of people are getting bored. So we'll cover the Catkin workspace in some time, and let's have some like let's see the simulation now. Okay, so I just want to ask everyone, like is that, are those package installations complete? You can just reply yes, no in the chat. Were you able to install them, and did you get any errors? Okay, guys. So I just want to ask you if you have installed these packages. These ones. So if you have installed them correctly, you can go to Catkin Workspace and do Catkin make. So in a video I posted earlier, we created the Catkin Workspace, and then in the SRC folder, you will see these four new packages that you have just cloned. Okay, I will just start with the Catkin Workspace thing. So now all you have to do is go to Catkin Workspace, cd to Catkin Workspace, and do Catkin make. Okay, your Catkin make should be successful at this point. And you can test if the Turtlebot 3 was correctly installed, like the package was installed. First, you need to source the Catkin Workspace like environment variables. Like in whichever terminal you are, just source the environment variable. So the command to do that is source command to do that is source, and then tilde slash and Catkin Workspace, and then there's a folder inside it called devil slash setup.zsh or bash if you are not using ZSH. Okay, once you have loaded the environment variables, then you can export the type of Turtlebot 3 that you want. Okay, so in our case, we will be using the waffle for the waffle model. So load this, and then you can do the empty world.launch. So if you can launch the empty world and the Turtlebot gets spawned at the origin, then you have correctly installed the Turtlebot 3 packages. So I'll just do a quick poll. Okay, so can you see the poll? Is Catkin make working, and is the Turtlebot 3 spawned in Gazebo? So this program, this simulator where the Turtlebot 3 gets spawned is called Gazebo, and it is just like real life. It has its own physics. And one thing I would like to share is that this real-time factor that you see, this indicates how fast the simulation is compared to real life. So like this one is currently running slower, and this is just one Turtlebot. So if you have like a dual boot system or something, this will be closer to like 0.95, 0.99. A real time factor of 1 means that the simulation time is the same as the real time. Okay. Okay, so let's continue with the presentation. Okay, so Catkin make is working. Turtlebot 3 is not spawned. Okay, so can you post the error in the chat, or can you like message me whatever your error is? Okay, so let's talk about Catkin Workspace. So Catkin Workspace is the directory in which all of our packages are. So it has a directory structure that's created by Catkin make. So we have three main folders in Catkin make. Catkin Workspace: build, devel, and SRC. So before you do Catkin make, you should source all of your environment variables in the terminal. So the command to source them, like the source /opd ros melodic setup.bash or setup.zsh. This one is included in the bash rc file. I covered this in the video that I posted, and so this will automatically be sourced when you open the terminal. And the next command that you have to source is the one we covered here. It's this one. So source, you go in Catkin Workspace, and then you source the setup.zsh. So when you source this one, uh, your your environment variables corresponding to your workspace are loaded in your terminal, in that particular terminal. So you might have multiple workspaces. If you want to change workspaces, you can load you have to load the environment variables of that particular workspace. So I'll give an example. Like in this one, like in home, I have two workspaces. One is called Catkin underscore workspace, and the other one is called ROS workspace. So if I want to execute packages that are in Catkin underscore workspace, so I have to load the setup.zsh file in the devel of Catkin underscore workspace. Okay. So the structure of the Catkin workspace, this is made by Catkin make, and uh, SRC. SRC is where our packages are, our ROS packages are. So in some time we will be cloning the Turtlebot 3 PID Git repo inside the SRC of our Catkin workspace. Okay. So the SRC contains the ROS packages, and it has all of the code. The devel and the build folders are the ones that we don't have to mess with. Okay, and they are created by a Catkin make. So the order to source environment variables is this command, source opt ROS Kinetic setup dot zsh or dot bash, followed by your devel setup dot bash of your particular workspace. Okay. So in order to check your environment variables, you can use this command, export grep ROS. So see, if I do export, then I think this is called the pipe symbol. Okay, so you'll see all of the environment variables here, like what's your version of ROS. It's ROS Kinetic. Okay, it's running Python 2, and what's the package path, like home KSA Catkin workspace. Okay, so that's the package path. So if I do the source for OPT, like in this one, source OPT ROS, and you will see that the ROS package path has changed. Okay, it was the Catkin workspace before, because we had sourced Catkin workspace devel setup.zsh. And if you source the OPT ROS Kinetic setup.zsh, then your ROS package path will be changed. So you see, you have to follow the structure for sourcing them. Like first source OPT ROS Kinetic setup.zsh, and then source the Catkin workspace devel setup.zsh. Okay, so don't get confused. Dot bash or dot zsh depends on whatever you're using. Okay, so in the video that I posted earlier, we started using dot zsh. Okay, we were using zsh. Okay, moving on. Yeah, so see, ROS master URI is the URL where the ROS core is being executed. So this is the URL. Okay, and package path contains the path on your hard drive where ROS packages are located. So you saw that the package path was changed when we sourced different different setup.zsh files. Okay, so now what are packages in our Git repo? What I have uploaded is a package, is a ROS package. So this control underscore bot is a ROS package. Okay, so ROS package has a folder inside it called launch, where it has the launch files. It has a folder called scripts, where it has the Python script or whatever scripts you have. Then it has a src folder. Okay, and so here you have your source files. Then in launch folder, you can have your launch files, and you have cmakelist.txt and package.xml. Okay, cmakelist.txt, it has these rules for compiling your program, for compiling your package. So when you do catkin underscore make, it uses the cmakelist.txt and the instructions in it to 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 like build your Catkin workspace. Okay, so I'll show that. See, so here it lists like the CMake minimum version. Which version of CMake do you want? What's the name of your ROS package? So in our case, it's Controlbot. Then it finds the required dependencies for your package, like it needs ROS CPP, ROS Py, std underscore messages. So all of those things need to be installed. If you don't have them installed, you'll like see you'll see that in the errors. Okay, so that was the that is the cmakelist.txt, and then there is the package.xml. In package.xml, you can see that this is using XML, and we have the version, we have the description, and which other dependencies we have. All of that is listed in the package.xml. Okay. Okay. So for our Turtlebot 3, we have the Catkin workspace, we have src devel build. Okay. Inside the src, we'll have the ROS package called control_bot, and it will have further directories in it: src, launch, and cmake lists and package.xml. So src, and we also have a folder called scripts where our Python script will be. Okay. So now let's go on and clone that directory. Okay. So I want all of you to go to your Catkin workspace, cd to Catkin workspace. Okay. cd to your Catkin workspace, and then go inside src, because src is where we clone our ROS packages. Okay. So cd into Catkin workspace, and then cd into src. Okay. And after doing that, you just have to clone this repository. Okay. And after you have cloned it, try doing Catkin make. First come one directory out. You always do Catkin make in the main workspace, which is the Catkin_workspace. So come out one directory and then do Catkin make. Okay. So it seems that I have cloned it 2 times. So see, when you do the git clone, you'll get the folder called Turtlebot_3_PID. Go inside that folder and you'll find the ROS package there, control_bot. Okay. So you take that ROS package, cut it, and paste it in the src. Okay. And then just delete this Turtlebot3PID, because what we need is the ROS package, and that ROS package is control_bot. That's it.
Can you please repeat this last thing again?
Yeah, sure.
Regarding which?
So so I'll just delete control_bot. So everyone right now should have these 4 packages. If you have installed all of those packages that I told you. So everyone at this point should have these 4 packages. Okay, which were like first cloned, then we did Catkin make. Okay, so we should have these 4 packages. Now what I want you to do is clone this particular repo. This repo is called Turtlebot_3_PID. Okay, so I want you to clone this repo. Clone, and then the link for the repo. Okay, so once you clone the repo, you'll get the folder named Turtlebot. Turtlebot 3 Turtlebot underscore 3 underscore PID. Okay, and just cut this control underscore bot folder and paste it in the SRC. Okay, because the control underscore bot is the ROS package that we need. This was just the Git repo, so delete it.
Okay, thank you.
Yeah. And after you have done that, after you have the control underscore bot in the SRC folder, you need to go one folder out in the Catkin underscore workspace, and you do Catkin make. So Catkin make will ensure that all of the packages are in the correct places, and it will include the things required for running this package in the build and devel. Okay, so you have to do Catkin make, and it will take some time. So once you do that, you can write yes in the chat. Once your Catkin make works, you can write yes in the chat, or otherwise you can post whatever error you have. So I'm waiting for you to post a yes or your error. Okay, cool. I got one yes. Feel free to ask me whatever like doubt you have. Just unmute yourself and ask me whatever doubt you have, or you can even share your screen. I can enable screen sharing. Yeah. So were you able to clone the repository? I would really appreciate a response, like yes, no, anything. Okay, so far 4 people have gotten it right. What about the other 6 people? Again, if you have any problem, you can text me privately, or just unmute yourself and ask your doubt. Okay, so I'm moving on. So I'm assuming that you have cloned the repo, and you have cut the ROS package control underscore bot. You have it in SRC of your Catkin workspace. Your Catkin make is working, and now we will move on. Okay. So now I need you to open a new terminal. And in that terminal, first of all, you have to source the environment variables. Okay. So source opt ROS Kinetic setup.zsh. If you haven't included that in your bash RC, okay. First of all, source this, then source Catkin workspace devel / setup.zsh. Okay, you have to source these like two setup.zsh files, and it is really similar to like whatever is the content in these setup.zsh files. That content is executed. It's just like executing those commands in the terminal. Okay. So after you have sourced your environment variables, now what you need to do is you launch the empty.world. Okay. So once you do the empty.world command, sorry, I went that over too fast. I'll cover that again. So the command to launch the a gazebo empty gazebo world with just the Turtlebot 3, the waffle spawned in it at the origin is ROS launch and then space and then name of the package. Name of the package is Turtlebot 3 underscore gazebo and then the name of the launch file, Turtlebot 3 underscore empty underscore world dot launch. Okay. I can post this command in the chat. Okay, so is this command working for you? Provided that you went through with the Turtlebot 3 installation, all of the packages. If you have any error, please message me. Is the Turtlebot being spawned? Okay, perfect. So the Turtlebot 3 is being spawned in the empty.world. Okay. So now we can start to look at what nodes are there, what topics are there, what's the format of the messages that are being published. Okay, and we can publish messages from our side to the Turtlebot. Okay, on the topics that we see. Okay, so now I need you to launch one other terminal. Okay, and in that terminal do ROS topic list. You see the topics that are available at this point. So when you do ROS topic list, you will see that you have all of these topics. So you can look at the contents that are being published to that topic using the command ROS topic echo and then name of that topic. Okay. So suppose I want to see the messages that are being published to the topic called /odom. This corresponds to the odometry. Okay. So I'll do ROS topic echo /odom. Okay. So see, I got the see. I hope you can see this. So this is being updated live. This is the message that is being published to the topic called /odom. This corresponds to the odometry of the Turtlebot. Okay. So see, that's the Turtlebot right there. Okay. And what position do you see? You see position XYZ 000, orientation 0000. Okay. So orientation is in the quaternion form, but let's not focus on that. Let's just focus on the position for now. Let me just move the Turtlebot a little. Okay. So click on the Turtlebot, move it. Okay. So see, as I moved it, the Y changed because I moved it in the Y direction. So this /odom is being updated, and you can even click on it. Okay. Change it to the cursor. Click on the Turtlebot, and you can go in the pose here, and you can change whatever X you want. Okay. So 1.3, and the Turtlebot will be spawned there. Okay. If you want to change your viewing angle, you can just press shift and then the middle mouse. Press shift and middle mouse, and you can change the viewing angle. Okay. So we see here that when we do ROS topic echo /odom, we can see the contents of the topic. And right now the X and Y position is 1.3 and 1.9. Okay. So to stop it, press Control plus C. Okay, it stopped. So that was the topic. Okay. Now let's take a look at the nodes that are there. ROS node list. It's gazebo is running, gazebo GUI is running. Okay. Okay, let's now continue with the PPT for some time now. So see, this is the waffle that we just spawned. This is the burger. The Turtlebot 3 has 3 variants. And I already covered this, that when we do Catkin make, it will compile your whole SRC directory, and we have to execute this in the Catkin workspace directory. We have to execute it from the workspace directory, not within the SRC. We have to get to the Catkin workspace directory and then do Catkin make. There is also option for compiling just one package. So you use the argument only package with dependencies, and you give the name of that package. Okay. So this is particularly useful when you want to save time, and suppose you change something in one package. Okay. So why do you want to compile the whole thing again? You can just do Catkin make for that particular package, and that's it. You save time. Okay. And sometimes it is also possible that some other ROS package has an error. So if you do Catkin make for the whole Catkin workspace, okay, I should give an example here. So see, this is the Catkin workspace, right? So in SRC, there are a lot of ROS packages. If you do Catkin make for the whole workspace, there might be an error in Turtlebot 3 messages, and it won't let you complete the Catkin make. Okay, so you can just do the Catkin make for control_bot and then continue to do your work. Okay, you can ignore Turtlebot 3_ messages without actually deleting it. Okay, so that's where that only packages the dependency argument is used. Okay, now so I'll just cover this from the top that you must have noticed that before launching the Turtlebot, before doing this command, we did this in the beginning. Export Turtlebot 3 model is equal to waffle. Okay, we defined the model. Okay, I'll just post this in the chat. Okay, so first you define the model and then you run the empty word. Okay, so when you're defining the model, if you're running this multiple times, you don't have to do this every time. You can include this in the .bash rc file. So just go in the .bash rc file. Okay, and you will notice that we have towards the end we have sourced opt ROS Kinetic setup.bash. Okay, so you can include that in the bash rc file so that every time you open a new terminal, you don't have to export Turtlebot 3 model every time. It is done automatically. Okay, just copy this command and include it in your .bash rc. Or for this case, it would be the .zshrc. Okay, because we are using ZSH and not bash. Open the .zshrc and then scroll down and then just enter this command. Okay, so you're just defining the Turtlebot 3 model, that is waffle. You don't have to do this every time, and you can also source the Catkin workspace, because for this workshop we are just using one workspace, so you can include it in the bash rc file. You don't have to do it again and again. Okay, save the file, save the .zshrc, and then just source it. Source space .zshrc. Okay. And now you'll notice that if I open a new terminal, and do the Turtlebot launch file. Okay. Oh, so you'll see that I did not have to specify the model, and let's close this as well. Just make sure you close all instances of Gazebo before you try this. So I've closed everything now, and you'll see that when I launch it, I don't have to specify the model because it has been specified already in the .zshrc. Okay. Yeah, see, so it's on the origin, right? Yeah. Okay, press Ctrl+C and close that. So we can include these export commands in the .zshrc. Okay. Now moving on. Let's talk about ROS launch. Okay. So the command that we used, to launch the empty world, ROS launch turtlebot underscore 3 gazebo, turtlebot 3 underscore empty underscore world dot launch. Okay. So let me again cover the format for this command. So turtlebot 3 underscore gazebo is the name of the package, and turtlebot 3 underscore empty world dot launch is the name of the launch file. Okay. So launch files, they have a format. We'll be covering that format, and they also have like you can also have arguments in that launch file, so that launch file is more customizable, usable. Okay. So now let's just look into that turtlebot 3 underscore gazebo package. Okay. So just search here turtlebot 3 underscore gazebo in your Catkin in your src folder of your Catkin workspace. Okay. Turtlebot 3. Okay. Once you find that, go inside it. Go inside the launch. Okay. And here you see a lot of launch files. Find the empty world.launch. Okay. So see, if you look at this file, okay, I'll just open this in Sublime. Huh. So, look at the format of the launch file. In the launch file, you have these arguments called X, Y, and Z, where you can mention the position at which the turtlebot 3 is spawned. Okay. And here you see that this is a XML format. Okay. And so this is much more readable now. You'll see that this is the XML format, and here the entire launch file is included within the tags launch, and then within that you have your argument name where you define the model. The default is environment, like turtlebot 3 underscore model. So this is the one that you define in your ZSHRC, turtlebot 3 underscore model waffle. Okay. So that default value goes here. That particular model is spawned. Okay. And then this is the argument name for X position, Y position, Z position. Okay. So I can change these, and like the turtlebot will be spawned at that particular location. I can save this empty world.launch and then do a Catkin make. Catkin make in the Catkin underscore workspace. Okay. You can do a Catkin make and launch it. So we'll notice that the Y position will be by default 2. Okay. So you see that the Y position is by default 2. We can also pass the arguments while going for the while writing that command. Okay. So argument name is x underscore position, right? So here you can just mention whatever your x position is, like x position, and then I think this was the one. This was the format for it. We can try like 1.5. Yeah. So see, we changed the y position in the launch file, but then when we were executing the command, when we were starting that launch file, we passed the argument for y in the terminal. Sorry, the argument for x in the terminal. Y was specified in the launch file. Okay, so that is very helpful. That can make your like the simulation configurable on when you start it using the terminal. Okay, I can even spawn the Turtlebot at a height of 10 meters and then let it fall. Okay, now let's do that. Height underscore position is equal to 10. So here you're passing that argument using the terminal. Okay. Weird. Didn't fall. Oh, it fell too fast. It fell too fast. Yeah, that's the thing. Okay. So it was spawned at that position, but when we opened it, it had already fallen. Okay. So that's the thing about launch files, and you can include these files as well. Okay. So you can use one launch file to launch any number of launch files that you want to launch. Okay. So like here, see, include file is equal to, so that's the format. So it finds Gazebo ROS. That's the package name. It goes inside the launch folder for Gazebo ROS, and then it launches empty underscore world.launch. Okay. And then for that particular launch file, you also have the arguments. Okay. You can change these arguments. Suppose you want to go headless for Gazebo. You want to pause it or whatever you want to do. You can pass the arguments. You can change them. Okay. In while executing the command in the terminal, you can mention those arguments. Okay. And then finally we have this node package is equal to Gazebo ROS, and then type is equal to spawn model arguments. So the arguments that we defined earlier, see, arg model and arg x position. This was defined here. Model was defined here. Okay. And z position, all of them were defined. Okay. So that's the thing about launch files. You can use one launch file to launch multiple launch files, and that gives you the advantage. That gives you the advantage of simplifying your entire pipeline. Suppose you want to launch 10 files, like you want to start Turtlebot, and then you want to start something else, then something else. You want to spawn a building. You want to start your code for doing slam or something. You want to start your camera. You can include all of those things in one launch file. It makes your code neater. You just launch that launch file and you're done. Okay. Okay, so this is just covering all of the things that I've just told you. So all launch files are contained within a launch tag. Arc tells you to create more reusable, configurable launch files. Okay. And then that's the format for the node tag. You specify the package and the node name, the type of output, all of those things. So ROS node list, we have already covered that. So ROS node info. So ROS node list, you have these nodes list. Then you can use ROS node info to look at the subscriptions, the connections, and the topics that it's generating. Okay. So let's execute this ROS node info. It tells you everything that there is about the node, about the nodes that are currently running. Okay. So, so I hope you, let's just do it again. ROS node list. It will tell you all the nodes that are there. Okay, Gazebo, GUI, ROS out, all of those nodes. Now you do ROS node info, and then you choose one of those nodes. Okay, suppose we choose Gazebo / Gazebo. Okay, so it tells us a lot of things here. I should. See. So the / Gazebo has a lot of publications and it has a lot of subscriptions as well. Okay. So this node is publishing all of these topics. Okay. All of these topics. See, /odom is also there. Okay. And then joint states, the IMU data, TF data, the clock, all of those things. And then it is also subscribing to these topics. Okay. It is subscribing to CMD_well. Okay. So that's the command velocity. Command velocity is that topic which we will use in the subsequent slides to send messages to Gazebo to control the Turtlebot. Okay, so we see that the node named /Gazebo, it is subscribing to a topic named CMD_well. So we know that it is subscribing to that topic, and now using the terminal, we will publish to that topic. Okay. So see, if you'll get back to the Git repo again and scroll down, see, one way to move the Turtlebot is by publishing to the topic /CMD_well. Okay. So this command is kind of complex and like you have to follow the format. If you don't get the format right, it won't move. Okay. So the best way is to use autocomplete. Press tab. Just use that. Okay. So let's just do now. We know that there is a topic called _CMD_well. Okay. So we will be publishing this message, particular message to that topic. Okay. So just type ROS topic, publish which topic, CMD_well. Okay. And then we just specify the message, geometry, press tab, okay, and then press tab again. It will auto complete it for you. Now remember, this is the velocity that you give it, that you give to the Turtlebot. Okay. Control Windows key left. Slide the window to left. Okay. Now you will see that the control Turtlebot will be moving. Okay. Now we have the option to specify the angular velocity, like angular velocity about x-axis, y-axis, z-axis, all of those axes, and the linear velocity. So okay, let us just give a linear y velocity of 0.1 meters per second, and angular velocity z of like that's the yaw. Okay, so the rotation about z, let's give it a angular velocity of like 0.5 radians per second. Okay, so see, it started moving, and you'll see that it won't stop. Okay, let's try with a higher velocity. Let's increase the y velocity to like 0.9. So it won't stop moving. Okay, so in order to make it stop, we have to publish velocities like the zeros, all velocity zero again. Okay, it doesn't look very good, so let's increase the y velocity. Okay, 5.9. So in order to stop the Turtlebot, you have to publish the message with the XYZ and the angular velocities all set to 0. Okay, and if you want to start it again, you just change the velocities, whatever velocities you want. Okay, and then press enter. Okay, so surprisingly, the Turtlebot is not moving. Okay, I'll have to look into that. Let's restart the process. I think the previous message that we passed on to it, that was not like that was not killed. So let's restart it once. For that, just for making sure everything is all right, do a Catkin make. Do a Catkin make for the Catkin underscore workspace. Then load your environment variables. This is the most important part. 90% of the times when you're a beginner, you forget to load your environment variables, and then you're like, what did I, what wrong did I do? Like, so just source your environment variables. Okay. After you're done sourcing your environment variables, let's just restart it. With no position arguments. Okay. Okay, it seems that Gazebo has an error. You can just type empty and then press Control plus R. So it will find that command for you. Okay, so Ross, like it is working. Like the Turtlebot has been spawned, and now let's try publishing the message again. So Ross topic pop. Geometry messages. Press tab, twist, and linear. Okay, so that's the basic 0 0 0. Everything is 0. Okay, and after that, let's just try giving a y of 2. Okay, I don't know why it is not working at this point. That's the thing about robotics. When you're doing a live demonstration, things have a very high probability of not working when you want them to work. So that's why you should always record videos and post them. I'll give one more try and then we'll continue with the presentation. Okay. Okay, so it seems that the angular velocity is working. So let's just give it a 0 to stop it. The linear velocity has some problem with it. Okay, maybe a wrong format. That's why I don't like to use autocomplete. Okay, so it's working. Okay, the Turtlebot is there. It's going in the which direction? X direction. Okay, so let's just stop it now. In order to stop it, we'll have to again publish the message with the X velocity 0. Okay, as soon as you publish that, the Turtlebot will be stopped, and in that time, it has already reached here, I suppose. Yeah, so let's just click on the Turtlebot and then look at its pose. Okay. We can also subscribe to do the ROS topic echo for the ODOM and look at the location. Okay. So see, the location for Y is -112, X is 23.8. Okay. See, so it's the same with the gazebo, and let's just spawn it at the origin. So I think the problem earlier was we were trying to set the velocity for Y, and in the launch file, we have defined the argument for Y. So both of them get conflicted. That's why it was not working. Okay. Screen share was stopped. Sorry for that. Yeah, I hope you can you see my screen?
Yes, sir.
Awesome, awesome. Okay, so that's how we publish messages to a particular topic, and here we are reading those messages from the ODOM topic. Okay, I just close that, and you can also control the Turtlebot using the keyboard. So the command to do that is in the Git repo, and it's a pretty simple command. So the command is from the package called turtlebot3_teleop. So that's for tele operation. You can use your keyboard to control the Turtlebot. So when you launch that, it looks like this, and you can just press keys and control the Turtlebot. Okay. Let's complete the presentation, and then we will go over the control underscore bot, control underscore bot package, ROS package that we downloaded. We'll go over that and we'll execute the code, and I'll go over the code. Okay, and then the workshop will be done for today. Okay, so yeah, ROS topic list, I've already covered that. So there's also ROS topic info. So if you have something running, like, if you have this particular launch file running and it launches this Turtlebot in the empty world, okay, then you can do ROS topic info to check which nodes are publishing to a particular topic and which nodes are subscribing to a particular topic. Okay, so as we saw that the gazebo node was subscribing to the topic called /odom. Okay, so we can do ROS topic info, and then the name of the topic. The name of the topic is /odom. Okay, so see, we see here that odom is published by gazebo. Okay, /gazebo is the name of that node, and if we launch the Turtlebot teleop, then teleop will subscribe to odom because it needs to see the position of the Turtlebot in order to control it using the keyboard. Okay. See, if I launch this, there's our Turtlebot. I can press keys to control it. Okay. So it's like going forward, left, right, and then stop, whatever. Okay. And now you do the ROS topic info odom again. Okay, that's the speed. You should have subscribed to it. I don't know what's happening. Anyways, you get what I was trying to say, that you can see the information of a particular topic, whatever topic you want. Okay, and you can see which publishers are there and which subscribers are there. Okay, so we have all of these topics and we can see all of them. Okay, so let's look at the topic cmd underscore well. Okay, and I got why it was not registering that, because we were not giving any commands. Okay, I can't do both of them at the same time. Anyways, so if I subscribe to the cmd underscore well, then we'll see that the subscriber is /gazebo. Okay, so /gazebo, that's the name of the node, which is this program right here. It is subscribing to the topic named cmd underscore well, and then we have another node. That node's name is turtlebot 3 underscore teleop. Okay, that node is publishing messages to the topic named cmd underscore well. Okay, so both of them are coordinating with each other to control the Turtlebot. Okay, so I've changed the velocity back to 0, and let's just bring our Turtlebot back home. Okay. So now I need to stop my video for some time. Okay. Moving on with the presentation. So we've already done this for the topic named /odom, and we saw that the odometry had these things for the CMD well, like XYZ and the angular and all of that. Okay. If you want to see. Okay. So that's the same format of for CMD underscore well. So that's the format in which we sent our message earlier. Okay. Now, if you want to see the format of the message, then you use ROS message show and then the message type. Okay. So in our case, when we use the publish messages thing, uh, when we published messages to the topic called CMD underscore well, there we had this format. Okay. And we can see that these numbers are float, the data type, the float. Okay. So if you want to see that what's the data type, how should you pass the message? Okay. You want to see that, then you just execute this command here, right here. Okay. So ROS message show and ROS message show geometry messages and then twist. Okay. And now ROS message show geometry messages twist. You see the format. Okay. That it's a vector, it has floats inside it, angular velocity also vector, floats inside it, all of that stuff. Okay. And so okay. What's the time? What's the time? Okay, it's 10:25 p.m. Okay, I'll summarize it quickly. Okay, it must be getting late. So we've covered all of that, and now let's just run. I'll just take 5 minutes. So hold on for 5 minutes. Let's just execute the control bot ROS package that we have already compiled. Okay, so the commands to compile it are here, and we already have the empty world running. Now all we need to do is you need to go in the Catkin workspace, src control bot, go inside the package, go in scripts, and yeah, the one request in go in src and delete this file. Okay, and then go in scripts and open right click, open in terminal, and then make this final.py executable. Okay. Make it executable. chmod plus x final.py. Okay. Once it's executable, we can use rosrun to run it. And now just use rosrun control bot final.py. Okay. So the advantage of using rosrun is that you just mention the name of the package and the name of the file, and it will find that file for you and execute it. Okay. So let's just run it. So we see that it is asking for lower range for the X and Y coordinates. So the way I've written it is that the Turtlebot is spawned at a random location. You specify the coordinates and it is specified within that square at a random location within that square. And then you tell it where to go. It uses a PID controller to go to that location. Okay. And now, so you enter the lower range for generating X and Y. Suppose we want the random location to be between 2 and 4. Okay. And the angle can be between 20 degrees to 80 degrees, and it generates a random location. Okay, so it converts by itself to radian, and then it generates a random location 3.69 to 2.79, and then we want to go to suppose 4.5 and 5, and the angle should be like in degrees, like 60 degrees. Okay. So now see, the Turtlebot was spawned at that random location, and now it will go to the location that we told it to go. Okay. So I've set the velocity very low so that we don't accumulate a lot of errors and it has time to clear out the errors. Okay. So now the Turtlebot is moving at that particular position that we specified. You can see it moving. Okay. And then it will stop there, and once it stops there, it will adjust its angle. Okay. So I'll just take 1 minute to go over the Python script. So when you're running the Python script, you import ROS.py. Okay, that's important. And you import all of these libraries so that you can write the Python code and integrate it with the ROS. Okay, and here we have used two PID controllers. One PID controller is for the distance and one PID controller is for the angle. Okay, so we have defined a class here. And so here we have a publisher defined for the topic CMD well. This is where we publish our velocities to move the Turtlebot. And like we also have a subscriber that's listening to the topic called ODOM. Okay, so that's a feedback loop. Okay, you see the ODOM and you publish the velocity. Okay, so we calculate the error and we minimize that error. Okay, our error is the distance. Okay, we calculate the error in the angle, we calculate the error in the distance, and then we give the velocities, and then we take feedback from the odometry again. Okay, this is how we move the Turtlebot, and when it crosses a particular threshold, we declare that the Turtlebot has reached the goal. Okay, so you will notice here that the Turtlebot has stopped. Okay, and the angle is from the positive x-axis and it is at angle of 60 degrees. Okay, so that was the PID controller for the Turtlebot, and I hope you learned something today about the ROS basics. And I can do more workshops later, like in the winter break or in January. I'll also be free at that time, and we can do the Baxter thing then. And I have some more things that I would like to cover. Like we can cover some planning algorithms or perception algorithms, and we can do more interesting stuff using ROS. So this was a basic workshop, and I hope you guys like it. And I would wait for your feedback. I would share a form where you can give your feedback, any improvements that I can make. I know that I went a little too fast at times, and like might have been too much. So please write that in the feedback. Okay. Yeah. Thank you guys. So if you want to share anything, I'm here for 2 minutes. Otherwise, the workshop is over. Done. Thank you.
Thank you, sir.
Okay, bye. And I hope everyone is staying safe from the virus.
Yes, sir.
Yeah, like India and America, they are like competing with each other. If you have any feedback, please write that in the form. And I hope you enjoyed the workshop. Okay. Stay safe and see you soon.
Thank you, sir. Thank you, sir.
Okay. Good night. Bye.
Good night.
Thank you, sir. Good morning, sir. Bye.
Good morning. Bye.